back again with another video. This time we're going to take a little break from kind of learning to do new things, and let's just make sure we understand squares and square roots and what they mean. So, and there's this word, right? This word square. Why is that in there? Let's talk about it. Draw a square with a side length of 3. So look, I'm going to draw a square. I'm going to start right here in this corner so I end up having space for everything. And so this side length is 3 units long, right? 1, 2, 3. And if I want it to be a square, I of course have to, let me focus this. I have to make all of the side lengths the same. Okay, so we can see, right? This is 3, this is 3, this is 3. And what's the area? And the area is how much of these boxes it takes up. And it's 9 boxes. So the area of this square is 9. Okay, what if I were to do the same? I would draw a square and the side length is 5 instead of 3. So now I'm going to go 1, 2, 3, 4, 5. And of course it's got to be 5 on all sides. 2, 3, 4, 5. Okay, so here is a square that has a side length of 5, right? All the sides are 5. And what's the area? Now I could count, but you also might notice, well, I have 5 rows of 5, and so that area is 25 squares. So the area is 25. And what do I observe? I observe that if I take the side length and I do 5 times 5, I get 25. And 3 times 3, I get 9. And so what I realize, and this is why it's called squared, is that if I take the side length and I take this number and I square it, right, I get the area. If I take it to the second power, I get the area. That's why we call that squared, right? Now, why square root? Well, square root is the opposite of square. Here's where it comes from. Let's say I tell you, okay, draw a square with an area of 16 boxes. Can you pause? Can you do it? Draw a square with an area of 16 boxes. Pause and do it. Right? It would look like this. You'd say, okay, well, how am I going to get 16 boxes? Well, and I have to have a square, right? So it has to be the same on all 4 sides. Well, the only way that I could get an area of 16 boxes, right, here's 16 boxes, is by making the side length 4. Right? So the side length is 4. What if I wanted to draw a square that had an area of 4? Well, if I just want 4 boxes, I would have to draw a square like this with a side length of 2. So what do I observe? I observe if I take the area, and I take the square root of it, I get the side length. Right? So we can see that squared, a power of 2, and square root, they're opposites, right? If I take the side length and I square it, I get the area. And then I can do the opposite with square root. I can go from the area to the side length. So that's why these things are called square and square roots. Now, this is an interesting question. Can you draw a square that has an area of 20? Think about it for a second. I can draw a rectangle, right? Like I could draw a rectangle that's 5 by 4, and that would have an area of 20. But can I draw a square that has an area of 20? And the answer is yes, sort of. I could draw a square, right? Like look, here's this square has an area of 16, and this square has an area of 25. This has a side length of 4, and this has a side length of 5. What I would need to draw, if I wanted to have a square that had an area of 20, I would need to have like a little bit more, a little bit bigger than this and a little bit smaller than this, right? So what I would actually have is I would have 4 point something, right? It would still be a square. I would have to have the same length on all sides, but it'd be somewhere in between 4 and 5, okay? And if I wanted the area to be 20, okay, it'd be 4 point something. Now, these numbers, 25, 9, 16, 4, those are called perfect squares. And a number like 20 is not a perfect square, right? Because in order to make a square, I would have to use an ugly old decimal. So that's not called a perfect square. Okay, so we're going to talk a little bit more about that right now. But I want you to understand that there's numbers that are perfect squares, that I can draw a square on grid paper like this with a whole number. And there's numbers that are not perfect squares, where I can still take the square root, but it's going to be a decimal.